Okay, here we go. I hate to make the videos very long. I want them to be smaller, but I just have so much to say about each of these problems, even when I talk really fast. So on this example where we kind of left off in the last video, notice in the square there, I don't have just sine of plain old x. If I have an angle other than x, yes, it creates more steps. But the good news is we can follow the same pattern. We don't have to approach this in a different way, not in the general scheme of things and the general steps that we follow. I say, well, my sine function is to the first power, and so I'm going to separate constants and the sine function by adding or subtracting things to separate them. So subtract square root of 3 from both sides, and divide both sides by negative square root of 3 over 2. Sorry, by 2 to get negative square root of 3 over 2. Okay. And again, I'm just going to put a big box around this for right now. And so what we're after now is we have to come up with what angles are the sine is the sine function negative square root of 3 over 2. Okay, I know sine is negative still in quadrants 3 and quadrant 4. And I have a pi over 3 reference angle. Okay, so quadrant 3 with a pi over 3 reference angle would be 4 pi over 3. Okay. I'm trying to pause to let you think before I give it away. And a pi over 3 reference angle in quadrant 4 would be 5 pi over 3. Okay. I also know that the sine function has a period of 2 pi, so I'm going to add or subtract multiples of 2 pi to those values, okay, to get all my infinite solutions. Okay, but what I am solving for is purple box. What I did not solve for was x. Okay, I understand that the angle here, since I had sine of 2x, instead of x equals those values, what I really have is 2x equals those values. And my job, what I've been charged with in all of these problems, from number 1 to number 100, however many there are, okay, is I need to solve for x. So once I have these expressions written over here on the right, I've determined what they look like. Then I have to go back and solve this equation for x. Okay. So to solve for x, that means I get to divide both sides by 2. Okay. Hopefully I can do that without actually writing the divided by 2. That'd be a big mess up here. But if I have 4 pi over 3 divided by 2, that becomes 2 pi over 3. If I have 2 pi in, and I'm dividing by 2, then I'm left with pi in. Maybe I can in some sort of way. Right, divided by 2, divided by 2, divided by 2. Okay. That's a mess. Understand it's this whole thing over 2, whole thing over 2. So 5 pi over 3, if I divide by 2, is 5 pi over 6. Again, the 2's go away on the 2 pi in divided by 2. So here are my actual solutions to the equation that I started with. I'll zoom out here in just a moment. Okay. When I found that 4 pi over 3, when I found that 5 pi over 3, that was not equal to x, that was equal to the angle. The angle happened to be 2x. If this was x over 5, I would have x over 5 here. If this was x squared, that's out of our scope of our class for right now. Okay, but it was a 2x, so I divide everything by 2, and then I have my solutions to that equation. One more of these. Let's say we have sine pi x over 2. That thing plus 1 equals 0. I want you to try again. I have sine to the first power here. So all I'm going to do is separate the sine term from the constant term, divide by a coefficient if there is one. Okay, and then I'll go back and say the angle is equal to and find all those values. Okay, if you want to pause the video now, pause it. Solve for x. Go as far as you can and then turn it back on to see if you're right. So all I have to do in terms of separation is subtract the 1 from both sides. There's no coefficient out here in front of the sign. If this was a 5, I would divide by 5. If it was a 1/2, I'd multiply by 2. Okay, but this says sine of something, and if you need to draw a box around it, so you just focus on the box, or if you're a U substitution person, a couple of you have used U's in some of the problems. If you're good with that, I'm good with that. If you don't know what I'm talking about, just continue not to worry about it. Okay? But I know that the angle for which the sine is -1, I know sine is -1 at 3 pi over 2. Okay? That's the only place it's -1 between 0 and 2 pi, because I'm 0 at 0 and pi. I'm 1 at pi over 2, -1 at 3 pi over 2. I know that the period of the sine function is 2 pi. I didn't draw my box very big, so I'm going to come back and fix that. Okay, so stuff in the box. Okay, so the angle is 3 pi over 2 plus 2 in pi. I'm going to rewrite that down here because there's not a whole lot of extra things that I can scribble without being in the way of what I've already written. If I need to solve pi x over 2 for x, I'm going to have to multiply both sides by 2 and divide by pi. Okay, whether I do that all at once, whether I do it in 2 separate steps, I'm going to multiply by 2 and I'm going to divide by pi. Okay. What that does, hopefully blue doesn't garble anything for any of you, says I just have x on the left, and out of this mess on the right I just have a plain old 3. The pi's 1 away, the 2's 1 away. Excuse me. And if I have 2n times 2, there's 4n. Okay, my solutions don't have a 2 pi in them, they don't have a pi in them anymore, just 3 plus 4n. So if n is 0, x equals 3 would work right there. Okay. If n equals 5, x equals 23 would work. If I let n equal -1, that means -1 would work. Sine -pi over 2 plus 1 equals 0. Okay, but there's our infinite number of solutions. Play with some of these, read the directions, look at the examples. Again, some of them will restrict and say, I only care about the solutions between here and there. Some just say solve for x or find all solutions, okay, in which case you need your 2n pi's and your n pi's and so on. Okay, get a hold of me if you need me after playing with all these.